Hello and welcome back to another video on the concept of absolute uncertainty. In the previous video, we noticed that the absolute uncertainty is dependent on the measuring device. For an analog device, the absolute uncertainty is half the least count, while for a digital device, the absolute uncertainty is the least count itself. In this video, we are going to explore how the concept of absolute uncertainty will be put to use. We know that the basic mathematical operations are addition, subtraction, multiplication, and division. Whenever we discuss the concept of absolute uncertainty, we need to understand that the absolute uncertainty in the final answer of any addition or subtraction of measurements is the sum of all the absolute uncertainties of the measurements. Well, let me explain this with the help of mathematical tools. Let us define a function x which is expressed as a plus b, where I am making an assumption that a and b are measurements. Both a and b would be having their own uncertainties since they are measurements, and they are expressed as a plus or minus delta a, while b is expressed as b plus or minus delta b. In accordance with the statement, we need to understand that the absolute uncertainty in x will be equal to delta a plus delta b. What if I have another function y which is expressed as a minus b with the same measurements as here? The absolute uncertainty in y is also written as the sum of the absolute uncertainties in a and b. To further understand how this is applicable and where this is applicable, consider a rectangle. A rectangle with dimensions 10.05 plus or minus 0.05 centimeters and the breadth being 5.25 plus or minus 0.05 centimeters. Well, if you are wondering where and how these uncertainties have been popped up, we need to understand that these measurements of the length and the breadth have been made using a ruler. Now, if the question here is to determine the perimeter of this rectangle, we pretty well know the formula for the perimeter is 2 times length plus breadth. In this particular scenario, both the length and the breadth are measurements and are having uncertainties. Let's look at the maximum possible value of the perimeter and also the minimum possible value. The maximum possible value of the perimeter can be obtained by adding the uncertainty to the measured values, which means the length could be expressed as 10.10. I'm talking about the maximum possible length, and the maximum possible breadth would be 5.30. If we now consider the sum of this, we would end up having 30.80 as the maximum possible uncertainty. The maximum possible perimeter. How about the minimum possible perimeter then? The value here would be, the minimum possible value of the length would be 10.00, while the least possible value of the breadth would be 5.20. You would now have the minimum possible perimeter as 30.40. If we directly determine the perimeter using this formula, we would end up getting 2 times 10.05 plus 5.25, with the value adding up to be 30.60 centimeters. I hope all of us are on the same page until now. Now, in order to report the perimeter along with the corresponding the absolute uncertainty, P plus or minus delta P is equal to 30.60 plus or minus, well, let's go back to the formula that we have just taken down. It is delta A plus delta B. Therefore, 0.05 plus 0.05, and that repeats itself for the simple reason that we are considering length 2 times and breadth 2 times. 0.05, here is the uncertainty in the measurement of the length and the breadth, which is now reported as 30.60 plus or minus 0.20. If we now compare this range of the perimeter with the maximum possible value and the minimum possible value, we would notice that the maximum possible value here is in agreement with the maximum possible value as calculated in the section. Similarly, the minimum possible value of the perimeter based on this reported value comes out to be 30.40, again in agreement with the minimum possible perimeter as calculated over in this section. So, is this the only way in which we will be able to determine the absolute uncertainty? Well, let's try to generalize this. If you notice carefully, the absolute uncertainty can also be written as 30.80 minus 30.40 divided by 2, which is actually 0.20. Am I therefore allowed to generalize that the absolute uncertainty would be the maximum possible value minus the minimum possible value divided by 2? Well, if this is how we can express the absolute uncertainty, the reported value of the perimeter can in fact be expressed as the average of the maximum and minimum possible values. Therefore, whenever we add or subtract 2 or more physical quantities, the final answer can be expressed as the average plus or minus max minus min by 2, with max minus min by 2 being the absolute uncertainty. Hope you understood the content from this video. Do watch the next video to understand how the concept of absolute uncertainties can be applied to an experimental data. Do not forget to like, share and subscribe, and also do not forget to hit the bell icon. Thank you very much. Have a good day ahead.